Hi, welcome to the presentation of Burst, a benchmarking platform for uniform random sampling. So before going into the details and explain what it is about, if you don't mind, I will use Burst to launch some experiments, right? Uh, it can take some time, so now we can chat. So this Burst platform is about sampling and uniform random sampling. So why sampling? It's because for configurable system and software product line, it's quite infeasible in practice to explore every configuration, every variant, because it's just too costly to compile, build, pass the test suite, or measure the performance of all variants. So you cannot do that, right? So pragmatically and practically, what you do is to select a subset of configuration, so only a fraction of the configuration space. You select a sample, right? So you can try with some manual configuration. You just click, right, based on your knowledge, or you do that in an automated way with the benefit of being automated and also respecting by default all constraints. And there are different strategy to perform sampling. So there is T-wise sampling, let's say, but there is also random sampling. And random sampling is actually a quite strong baseline for effectively find bugs or for learning performance model. It has been shown in many papers. And then the challenge is, how to do that? How to truly generate a random distribution so that you basically don't forget some important option, let's say. And many people have considered this, many researchers and many practitioners are interested by that. And some clever algorithms have been developed. So as part of Burst, we have considered 10 samplers capable of doing random sampling. And usually, you expect that this sampler operates over feature models coming from the software product line community, or satisfiability SAT formula, more, more coming from the artificial intelligence domain. And of course, you can translate back feature model to SAT. So we support these two formalism here, and we provide a bunch of data, so hundreds of instances that are changing for samplers. And we show that, or at least you can experiment with many samplers, and you can try, for instance, with a quick sampler that has been published at ICSI 2 years ago. And this sampler, for instance, is unable to generate a truly uniform sample. And we have facilities written in Python and embedded into the Docker file in such a way you can check whether it's truly random or not. So quick sampler is not the only one to not be uh, in this category here. So if I'm taking here, distance-based sampling is also unable to generate random samples because it's another approximation of the random distribution. So you can play with the parameter here. So the reference sampler that is used for the checking of the uniformity, the sampler under study, many interesting parameters that can have an effect on the performance, and also many data out there. So you can do that also on folders, and it's quite easy to benchmark. And you can benchmark either a sampler is able to scale, right, to generate a sample in a limited amount of time, or to check whether it's uniform. And some are not scaling and not uniform. Some are scaling but not uniform. Some are uniform but not scaling. And according to our experiments, and you can verify it with Burst, uniform random sampling is actually an open problem. So we believe it's a useful input contribution for the software product line community and for the artificial intelligence community.